Hi students, this is Sivakumar, 10th Standard Mathematics, Chapter number 3, continuation of exercise 3.12. Now problem number 5. Listen, a pole has to be erected at a point on the boundary of a circular ground of diameter 20 meter in such a way that the difference of its distances from two diametrically opposite fixed gates P and Q on the boundary is 4 meters. Is it possible to do so? If answer is yes, at what distance from the two gates should the pole be erected? Right? First we can draw a circular ground of diameter 20 meter. Circular ground. Diameter 20 meters. You know that diameter is the chord, it's the longest chord of a circle passing through the center of a circle. This is one boundary of the diameter, so one extreme end of the diameter, another extreme, two extremities. Two extremities means two end points of the diameters. In that end points, two gates are there, gate number 1 and gate number 2. According to this question, a pole has to be erected on the boundary of the circular ground. I can anywhere on the circular ground. I take here a pole. I consider the pole as A. So once again I tell you, circular ground of diameter 20 meters, 20 meters. At the end points of the diameters, two gates are there. Gate number 1, I consider gate number 1, that is P. Then Q is another gate, that I consider as gate number 2. One pole has to be erected according to that question. That pole has to be on the boundary of the circular ground. I have taken over here. Anywhere you can take, I have taken over here. Now, I am going to join P and A, Q and A. PA and QA. I consider the distance between gate 1 and A as x meters, and the distance between gate 2 and gate Q and the pole as y meters. Given the difference between the two gates equals difference between that PA and QA equals 4 meters. Here it is. What is given? The difference of its distances from two diametrically opposed fixed gates P and Q on the boundary is 4 meters. Given x minus y, that is equal to 4 meters. which implies, that symbol for difference minus represents difference, x minus y, that is equal to 4 meters. Now therefore plus 4 comes left hand side, minus 4, that is equal to y, which implies y, that is equal to x minus 4. Then we know the point A lies on the circle, right? It is a semicircle only, you know very well. PQ is the diameter. Definitely this portion is a semicircle, half of the circle. Since A lies on the semicircle, definitely it will be a right angle. Already I have learned in 9th standard. Angle in a semicircle is 90 degree. From diagram right here, from diagram, angle PAQ, that is equal to 90 degree. Angle PAQ, that is equal to 90 degree. I write the reason also. Since angle in a semicircle is always 90 degree, remember. Since it is 90 degree, definitely this triangle PAQ is a right angle triangle. You know very well, one of the angles is 90 degree. We can say that triangle is a right angle triangle. So in triangle PAQ, in triangle PAQ, since it is a right angle triangle, we can use a Pythagoras theorem. Pythagoras theorem. Even we can say Pythagoras theorem. The side opposite to 90 degrees is called hypotenuse. For your reference, I draw the diagram here. Right angle triangle only. Which angle is 90 degree? Angle A. Then we have P and Q. A here, P, Q. Distance between P and A is x. So P and A is x. Distance between Q and A, that is equal to y. Y, that is equal to x minus 4. Instead of y, you can write x minus 4. Distance between P and Q, that is equal to 20 meters. P and Q distance 20 meters. This is the hypotenuse, correct? The side opposite to 90 degree. This is 90 degree. The side opposite to 90 degree is hypotenuse. I have learnt in trigonometry. Sorry, in geometry. The square of the hypotenuse equals, that is PQ squared equals sum of the squares of the other two sides. What are the other two sides? AP and AQ. AP and AQ. This is a statement of Pythagoras theorem. Square of the hypotenuse equals sum of the squares of the other two sides. What are the other two sides? AP and AQ. Now PQ can be replaced by 20. 20 squared equals AP, that is equal to x squared, AQ, that is equal to x minus 4 the whole square. 20 square, you know, that is 400. Then x square as it is. 400, that is equal to x squared plus the x minus 4 whole square. You have to apply the formula a squared plus b squared minus 2ab. We know that a minus b the whole square equals a squared plus b squared minus 2ab. A, that is x, b that is 4, a minus b, a that is equal to x, b that is equal to 4, a that is equal to x, b that is equal to 4, a that is equal to x, b that is equal to 4. Okay, now we have to simplify. 400 equals x squared plus x squared plus 16 minus 2 into 4, 8 into x, 8x, which implies x square plus x square, that is 2x square, minus 8x plus 16, and plus 400 comes right hand side, minus 400, nothing in left hand side. We can write 2x squared minus 8x, these two are constants only, 16 minus 400, that is equal to minus 384, that is equal to 0. 16 minus 400 minus 380, bigger number sign, minus, so minus 384 equals 0. Here 2, here 8, here 384, all the three numbers can be divided by 2. Divide by 2, 2 to get cancelled, x squared, minus 8 by 2, that is equal to 4, so 4x. 384 divided by 2, that is equal to 192, that is equal to 0. Now we can factorize. The coefficient of x squared is 1. 1 into minus 192 is minus 192. The coefficient of x equals minus 4. You have to find out the two numbers. Product of the two numbers equals minus 192 and sum of the same two numbers equals minus 4. So you take 192, keep on dividing by the prime number, and divide by 2. 9 2s are 18, balance 1, 2 6 are 12. Divide by 2, 4, balance 1, 2 8s are 16. Again divide by 2, 24. Divide by 2, 12. Then it is enough, it seems, because we have 2 2s are 4, 4 2s are 8, 2s are 16. 16 and 12 are the two numbers. For getting 4, straight away I write 16 and 12. For getting minus 4, have to introduce minus for the bigger number. Minus 16 plus 12, that is equal to minus 4. If you multiply the two numbers, you will be getting minus 192. Since it is an equation, you can directly write the values of x. X that is equal to, what is the coefficient of x squared? 1. Change the sign, that 1 becomes minus 1. Write minus 1 in the denominator. Minus minus get cancelled. 16 by 1 is 16. Plus divided by minus is minus. 12 by 1 is 12. So 16 and minus 12. 16 and minus 12. X is the distance. Distance cannot be negative. Here x represents distance between gate 1 and pole A. Distance cannot be negative, so we can write x that is equal to minus 12 is not possible. Therefore x equal to 16. Okay. Now I'm going to find the value of y. I consider y that is equal to x minus 4 as number 1. Therefore equation 1 implies y that is equal to x minus 12, correct? Y that is equal to x minus 4, x minus 4. What is x? 16. 16 minus 4, that is 12. Now we have 16 and 12. 16, this is 12, here 20. According to Pythagoras theorem, 20 square is 400, 16 square is 256, 12 square is 144, 256 plus 144, that is equal to 400. The question is it possible? See, is it possible to do so? Yes, it is possible. After that, if the answer is yes, you have to write the distances from two gates, okay, from the pole. First result, yes, it is possible. Yes, it is possible. Next one, the distance between the pole and the gate P equals, and the distance between the pole and the gate Q equals. Pole and gate P distance, what we consider, pole and gate P distance x. Pole and gate Q distance is y. First one x, second one y. First one x value 16 and y value 12. 16 and 12, that's all. 16 meters, 12 meters. Problem number 5 is completed. I'll be teaching the next problem in the next video. Thank you, children.